Dealing with the raster dataset is a challenging task, but in this video, I'm going to explain about how to get the information of the your raster dataset and then how to visualize it, even the histogram of the data, and also how to save the data in your custom format. This is the first step to become a data scientist or data analyst. So let's get started. Okay, all right, guys. We are in the Google Colab right now. So collab.research.google.com. So I'll cancel this and I want to create the new file for raster data analysis. So I'll create the new notebook and then maybe close this. And then first thing I want to do is I want to change this title. So I'll change this to raster data analysis. Okay, and then after that this Google Colab support lots of libraries by default, but if I check for the Rasterio, it's not available. So if I run it, it will throw an error, module not found. So for that actually we need to manually install it. So for the installation we can type the pip install Rasterio. Okay, if I rerun it again, so it will install the Rasterio package for us. So now it's downloading, and then here the successfully installed. Okay, so after that, for importing this package, so we can simply write it as the import Rasterio. Okay, so if I run it, so it will run. That means our Rasterio is installed successfully. And for like getting the version of this Rasterio, you can type the Rasterio dot underscore underscore and then version underscore underscore. So yeah, so it will output the version of your Rasterio. Right now I am using the 1.2.6. In the future it might update it and then you will get the new version. But if you want to work with me, then you can what you can do is you can assign the Rasterio version during installation, like pip install Rasterio equal to 1.2.6. Otherwise there might be update and my code won't might not be working. That's why we have to like provide the version number, and then I want to import it again and then run this cell again. Now I have this latest version. Okay, that's all about the importing and installation. I'll see you in the next. Alright guys, we imported our Rasterio package. Now we are going to read it using the Rasterio package. So for that, actually we have the land cover dataset we downloaded from CDS API Copernicus, and I clipped this TIFF file to the Nepal boundary, and now it's here Nepal LC 2020.tif. So I'm going to upload it here. So maybe what I like to do is I like to create the new folder and then name it as data, and within which I can now upload my data. So for uploading the data, actually I have here dataset, and maybe inside GeoDev I have this Nepal data. So one not good thing about this Google Colab is when our Jupyter notebook is restarted, or when we close this file, actually this uploaded file will be lost, and then we have to re-upload it again and then reinstall the package. So make sure if you are if your Google Colab is updated, or if you close this file and then want to reopen it, then you have to upload the data again, and then you have to rerun this installation as well. So now you can see I have this Nepal LC2020T file. So for reading this using Rasterio, it's just a one line of code. So you just need to, maybe I can write ds means data source, and then you can write Rasterio dot open, and then you have to provide the path to image. So for the image path, actually maybe I can write the in img, in image means the image path, and then maybe I can write copy this path and then paste it here. So after that, just I need this in image to read it. So if you type ds here, you will get the output something like this. So open dataset renderer and then name, and then by default this Rasterio will open our file in the read mode. So that means we can only extract the information about this image. We cannot do the like processing and cannot change the cell values, but later in the course we are going to change the values as well. So okay, so after that, what you can do is you can read it as the numpy array. So for that, maybe I can assign it as the data variable, and then if I type ds dot read, and then it will read our data source. So if I run it, so it will run our data source, if it will read our data source. So if I type data here, so you will get this array. That means we have this 255255 values around this cell, and then here is you can see three dots because this raster has lots of cells, so it cannot output everything within the same output box. So that's why this three dot and then this middle three dot represent the there are lots of data inside this file. So it's the general process of reading raster data. So in the next section we are going to read some metadata about this data. So I'll see you in the next. In this video, we are going to read the metadata of our this Nepal land cover 2020 map. So for that, actually what you can do is you can, like for reading the metadata, so you can write the ds.meta. So it will output you the all the metadata of your data, but sometimes it's missing something, so we need to manually see the other metadata like the size of the file and then the name of the file. These things we can read manually, but for here, what this metadata will output is we have this count. That means count one means we have only one band, and then the crs means the it's the geographic coordinate system 4326, which is the epsg, and then driver, it uses the geotiff driver. Of course our file is tiff, and then data type is unsigned integer 8. That means our value is between 0 to 255, and then the image height is 1485 and width is 2932, and no data value is 255. This inside cell, this 255 value represent the no data. Maybe these values are just like it's on the border of Nepal. That's why lots of the missing no data values are available there. But within this cell, there might be other values as well, because we downloaded the land cover data. There are the values like based on our land cover type. So this transformation represent the, this is the cell width, cell, I think width, yeah. And then this is the cell height. This, why this cell width and height are in 0.0027, it's like strange, right? So it's due to the our data set is in geographic coordinate system. So if we convert it to the projected coordinate system, then our cell size will automatically update it. I think it will update it around 300, because in the source of the data we downloaded, they mentioned that it's the 300-meter resolution data set. Okay, so let's fetch other metadata as well. So for getting the name of this file, you can type ds.name. It will output you the name of your file like this, full path. And then for getting the number of bands separately, you can write ds.count. So here is one, that means we have only one band inside this file. And then for getting the shape of this raster, then you can type ds.shape. So it will represent the your rows and columns. So we have 1485 rows and 2932 columns. And then for getting the width, you can type ds.width separately, wid, sorry, ds. And then this is the width is exactly similar to the number of columns, right? So for height also, you can type ds.height, so it is similar to the number of rows. And then for getting the driver separately, you can type driver. So ds.driver will output you the driver. So there are lots of things, lots a lot thing, so that you can stack it. But here just I am showing the some of these things. So for the coordinate system, ds.crs. And then for getting the transformation parameter, ds.transform. And similarly for getting the, if some of the raster has the description as well, so for getting the description, ds dot description, but right now it's none. And then for like getting the size of your data, then you can type, actually the size is coming from data, so you can type data dot size, which is the numpy array. So sorry, I don't have to provide this. So it is this size, so it's in byte, so you can convert it to the uh, megapixel, sorry, MB or KB as well. So for like what else, maybe for the data type, data.dtype, it will output you the data type, which is unsigned integer 8. And I think that's all. And one more thing, like getting the maximum and minimum value of your data, you can simply type data.mean to get the minimum value, which is 10. And then data.max to get the maximum value, which is 255, which is the no data value, right? So yeah, these are the some of the things, some of the like you can say it as a metadata about your data. So you can stack it one by one, or you can stack it in a combined form called ds.meta. But one thing that this ds.meta output does not cover everything, like name and then the description field, like this kind of things we have to extract it manually. So I think that's all about the reading metadata, and I'll see you in the next. Okay, in last video we read the data and then we read the metadata as well. Now it's time to visualize it. So for the visualization, actually we are going to use the show function from rasterio.plot. So let me import it first. From rasterio.plot, we have to import the show function, right? Now if you pass the your data source inside the show function, it will output you the map. So like this, it's the land cover map, right? It by default it uses the default cmap color map, which is coming from the matplotlib color map. So I'll provide you the link to the matplotlib color map in the notebook. And then so also we can, like as I mentioned, also we can pass the cmap parameter as well. So if I pass the cmap to spectral, is the name of cmap, so you will get the ender color map, right? It's cool, right? You might be worried where this spectral coming from, right? So for this, actually I have to search for the matplotlib color map, and then inside this matplotlib website you can get the color maps. So here if you scroll down, so it has the lots of colors, right? So if you want to generate your map based on this color ramp, so you can simply pass the name of your color ramp and it will automatically apply in our code. So maybe let me try this winter. So make sure it's the case sensitive, so you have to type the small winter, and then if I type winter, so I'll get the map in winter color, right? So in this way you can change the color map. Here are lots of various colors, so you can simply choose the nice color and then simply have to pass in the show function. Of course, you can pass the title as well. So if you pass the title here to the land cover map of Nepal, like this, it will output you the title as well here, right? So this is the cool way to like visualize your map in the notebook. So I think one thing I want to cover here is I want to cover which land cover classes is the most and which is the least in our map. So for get to know about this, we have the another parameter called show hist. It will print out the histogram of our dataset. So maybe I can remove the cmap parameter, and then instead of cmap I can write the bins, maybe 50 bins. And I think I forgot this. So hist, I have to change it to hist. Okay, now I get the result. So might be there is like 70, class number 70, which has the largest value, and then for this, like some of the value are small, that means some of the like class 200, and then the which represent the 200, and then I think between 100 and 150, this might be I think 120 or 30, it has the lowest class. Okay, I want to show you the previous PDF as well, product I think product guide from our CTS Copernicus website. So here uh, I think this value is between 50 to 100, and I think this is 70. So for the value 70 is tree cover need leaf. I think this category of class is higher in Nepal. And then for these around 200, this class are lower, that means around 200. Okay, 200 is bear area. So in Nepal, bear area is this much, very less, right? It's represent the frequency. So and then for the like 210, it's water body. Water body is also showing small amount because it's the 300-meter land cover map, so it might not see the small rivers and then small like water sources. That's why it's showing small. So I think that's the interpretation of your land cover data in the uh, of the Nepal. So in this way, you can visualize your data using Rasterio. I hope you enjoyed it, and I'll see you in the next. Alright, it's time to write the raster data. So for writing raster data, I want to create the new folder and then name it as output. And then what I will do is I'll upload the required dataset inside data folder, and then the output things will be inside the output folder. So now I am going to write the raster. Okay, so for writing the raster data, actually I want to create the new file inside output, and then I'll open this file with the with statement. What do I mean is I'll write with, and then I have to type rasterio dot open, and then I can provide the path to my output folder and then the file. So what I mean is I'll provide the path, and then maybe my output name will be Nepal LC 2020 out, means output file, and then I'll provide the TIFF as the file format. And then I want to open this in the write mode, so I'll provide the W options. And then here you can see here are the available options, so I have to provide these options one by one, because without providing these options we cannot write our raster dataset. Because for the raster, of course, we need width and height of cells, and the number of bands, and then the CRS parameter and transformation, and data type and no data value as well. So okay, so for this, actually what I can do is I can provide the driver first. Driver will be the d same as ds.driver, and after that I have to provide the height. Height will be the, as I showed you in the previous metadata section, ds.height, and then I have to provide the width as well, ds, and width will be ds.width. And of course I need the count as well. Count means the number of band, and then it will be ds.count. I want to make the same similar kind of file to the our input data. That's why I'm writing ds dot something. That means our metadata for the new raster will be similar to the input. And then for the CRS, actually CRS also ds dot CRS. And then for the transform, it will be ds dot transform. And for the data type, the type, it will come from the data instead of a ds. So data dot dtype. And then for the like I think that's all. We don't need to provide the no data value. Without no data also it work. And then I want to open this as a dst, means destination file. And then now sorry, I want to like tab it, and then I want to write dst dot writ, right? And then I want to write the same data. That means we generated for ds. So over here, maybe here, this data, right, is the same input data. I'm going to write the same data for output as well. So if I run this, so it will generate the new file. But okay, here is always the type error. So dth. Okay, now it ran. So if I see the product here, now I got the Nepal LC 2020 out.t file. That means I successfully generated the my output file. So if you want to visualize it, just download it, and then you can go to the QGIS or ArcGIS or whatever desktop GIS software you have, and then you can visualize it. Also, you can visualize it within the your Jupyter notebook as I showed above. So you have to first of all read the data set. So maybe I can ds out, and then I can read the data. So rasterio dot open, and then I can open the same file, this file. Okay, and then after that maybe I can show ds out. Okay, now my raster data will look like this. So this is the way of writing your data. So I hope you enjoyed it, and I'll see you in the next. This video is the part of the course Geospatial Analysis using Python. So if you are interested, you can buy the full course using the discounted link in the description below. I hope to see you inside the course. Thank you. Thank you for watching.